Hello, this is Mr. White. We're on Chapter 16, and this is Lesson 3, The Sun. My Planet Diary, Left in the Dark. On March 13th, 1989, a flood of electric particles from the Sun reached Earth, causing a magnetic storm. Bright streamers of color filled the sky as far south as Jamaica. But in Quebec, Canada, the storm brought problems. At 2:45 a.m., the entire electric power system collapsed. People woke up with no heat or light. Traffic snarled as traffic lights and subways stopped working. How could particles from the sun take out a power system? The magnetic storm caused an electrical surge through the power lines. Electric stations couldn't handle the electricity, and they blew out, taking the power system with them. What is the structure of the sun? Unlike Earth, the Sun has no solid surface. About 3/4 of the Sun's mass is hydrogen. About 1/4 is helium. There are tiny amounts of other elements. The Sun has an interior and an atmosphere. The interior includes the core, the radiation zone, and the convection zone. Figure 1 shows the Sun's interior. The core. The Sun produces an enormous amount of energy in its core, or central region, through nuclear fusion. In the process of nuclear fusion, hydrogen atoms join to form helium. Nuclear fusion requires extremely high temperature and pressure, both of which are found in the core. The total mass of helium formed by nuclear fusion is slightly less than the mass of the hydrogen that goes into it. The remaining mass becomes energy. The radiation zone. The energy produced in the Sun's core moves outward through the radiation zone. The radiation zone is a region of very tightly packed gas where energy moves mainly in the form of electromagnetic radiation. Because the radiation zone is so dense, energy can take more than 100,000 years to move through it. The convection zone. The convection zone is the outermost layer of the Sun's interior. Hot gases rise from the bottom of the convection zone and gradually cool as they approach the top. Cooler gases sink, forming loops of gas that move energy toward the Sun's surfaces. The Sun's atmosphere. The Sun has an atmosphere that stretches far into space, as you can see in Figure 2. The layers of the atmosphere become less dense the further they are from the radiation zone. Like the Sun's interior, the atmosphere is primarily composed of hydrogen and helium. The Sun's atmosphere includes the photosphere, the chromosphere, and the corona. Each layer has unique properties. The photosphere. The inner layer of the Sun's atmosphere is called the photosphere. The Sun does not have a solid surface, but the gases of the photosphere are thick enough to be visible. When you look at an image of the Sun, you are looking at the photosphere. It is considered to be the Sun's surface layer. The chromosphere. At the start and end of a total eclipse, a reddish glow is visible just around the photosphere. This glow comes from the middle layer of the Sun's atmosphere, the chromosphere. The Greek word chroma means color, so the chromosphere is the color sphere. The corona. During a total solar eclipse, an even fainter layer of the Sun becomes visible, as you can see in Figure 2. This outer layer, which looks like a white halo around the Sun, is called the corona, which means crown in Latin. The corona extends into space for millions of kilometers. It gradually thins into streams of electrically charged particles, called solar wind. What features can you see on the Sun? For hundreds of years, scientists have used special telescopes to study the Sun. They have spotted a variety of features on the Sun's surface. Features on or just above the Sun's surface include sunspots, prominences, and solar flares. Sunspots. Photographs show dark areas on the Sun's surface. These sunspots are areas of gas on the Sun's surface that are cooler than the gases around them. Cooler gases don't give off as much light as hotter gases, which is why sunspots look dark. Sunspots look small, but in fact they can be larger than Earth. The number of sunspots varies in a regular cycle, with the most sunspots appearing about once every 11 years. Prominences. Sunspots usually occur in groups. Huge loops of gas, called prominences, often link different parts of sunspot regions. You can compare sunspots and prominences in Figure 3. Solar flares. Sometimes the loop and sunspot regions suddenly connect, releasing large amounts of magnetic energy. The energy heats gas in the sun to millions of degrees Celsius, causing the gas to erupt into space. These eruptions are called solar flares. Solar wind. The solar wind is made up of electrical particles from the sun. Solar flares can greatly increase the solar wind, which means that more particles reach Earth's upper atmosphere. Earth's atmosphere and magnetic field normally block these particles. But near the north and south poles, the particles can enter Earth's atmosphere. There, they create powerful electric currents that cause gas molecules in the atmosphere to glow. These particles cause auroras near the poles. They can also cause magnetic storms, like the one that caused the blackout in Quebec in 1989. Figure 4 shows how the solar winds interact with Earth's magnetic field.